Today's session is about fundamentals and the future of data science. What is data? So data is normally, literally data meaning numbers previously. So now data also includes what? The facts, figures, that is numbers, and also information. We all know that information is wealth. So data is a collection of facts, figures, and information. And data is a powerful asset used across various fields and industries. Data is a powerful asset used across various fields and industries. For example, in scientific research, in healthcare, in business decision making, education, government and public policy, marketing and sales, finance and banking, manufacturing, energy sector, retail, sports and entertainment, transportation, environmental management, etc. Its effective use can lead to better decision making, increased efficiency, and innovative solutions to complex problems. So a course or a degree in data science provides a robust foundation of knowledge, practical experience, and valuable resources that are crucial for building a successful career in this dynamic field. So this is ever dynamic field. Okay, so now over to the presenter, Ms. Kavya Shri. She is doing integrated MSc in data science.
Thank you all for being here today. I'm Kavya Shri. Currently, I'm doing my MSc in integrated data science at Tyagarajar College of Engineering. So I'm excited to talk to you about the fundamentals and future of data science. So data science is an amazing field that helps us understand and use data science to make better decisions. So it's used in many areas like business, healthcare, sports, and in our daily lives also. So today I'll explain the basics of data science and show you how it's being used right now. And I'll give you a glimpse of what the future might look like in this field. So I like to start with a quote that perfectly captures the essence of data science. So data science is the art of turning data into actions by Daniel. So this quote highlights how data science is important to our real life. And also it tells how to make decisions, how we need to take the data and turn into actions. So now let me get into the agenda. What is data science and components of data science, AI integration in data science, algorithms, career paths in data science, and demand and salary trends and conclusion. So today we'll see all this topics and we'll see full meal of data science, and there will be some technical terms, but I'll give you some real life example and I'll make you understand. Data science is a multidisciplinary field that combines several areas of expertise. So first it involves statistical analysis, which is all about collecting data and analyzing numerical data. For example, imagine you are a business person trying to understand your sales trends over the last year. So you will almost use statistical reports to spot the patterns in your sales data, right? So this is how statistical analysis plays important role in data science. Coming to computer science. So computer science, this is crucial because we need powerful computers and sophisticated algorithms to process and analyze massive amount of data. So to give an example, think about how Google processes billions of search queries every day to provide you with relevant results in a millisecond. So this is how computer science comes into data science. And domain experts, in the sense, this means like, for instance, if you're analyzing healthcare data, understanding medical terminology and healthcare process is very vital. So you should know the basic algorithms in the field of data science. So this data science is integration of all this statistical modeling, computer programming, and data exploration and visualization. So I have given this image. You can clearly understand what is data science. And let's see the purpose of data science. So the purpose of data science is to extract meaningful insights and knowledge from both structured and unstructured data, like spreadsheets. So let me tell you an example. So unstructured structure, these things we will see in supervised and unsupervised learning in the deeper part of the slides. Now let me come to the goals of data science. So inform decision making. So data science helps business and organizations make better decisions. For example, Netflix uses data science to recommend shows and movies based on your viewing history. Likewise, can you give any example like how data science is used in decision making? Like I told Netflix. Okay, let me continue. So, solving complex problem. Data science can tackle complicated issue. For instance, it helps in predicting weather patterns, which can be crucial for agriculture and disaster management, right? So, next coming to patterns and trends. By analyzing data, we can discover hidden patterns. For example, in retail, data science can help identify which product are frequently bought together, leading to better inventory and management in the sales also. Why is data science? Data science is crucial because it helps us to make predictions and forecast. For example, methodologists use data science to predict the weather and help us planning our activities. In business, business persons use data science to forecast sales, ensuring they have the stock right. They stock the right amount of products in their businesses. So skills essential for data scientists, statistical analysis and machine learning techniques are very, very crucial if they are data scientists. And statistical analysis, understanding data and being able to interpret it accurately is the fundamental essence. So for instance, a data scientist might use a statistical analysis to determine the market campaign was successful or not. And machine learning techniques, we'll see some types of machine learning in the upcoming slides. And real world applications. So data science has many practical uses. One common example is product recommendation system. So think about like how Amazon suggests products you might like based on your past purchases. So this is data science in action, helping improve your shopping experience. So and driving the sales for the company also. So let's go to the next slide. Yeah. So foundations. When you are a beginner in the career of data science, then these are the foundations that you must. First is Python. So Python is a versatile programming language that's widely used in data science, and there are many important packages that we use in building a machine learning model. Particularly, I like to mention NumPy, Pandas, and sklearn. For example, Pandas helps in data manipulation and analysis, making it easier to handle large data sets. And NumPy is great for numerical computations, and sklearn is used for building machines. So these are some packages that we should know as a data scientist in Python. And R programming. So R is another powerful tool, especially for statistical analysis and data visualization. So it's just like Python. And statistics, as I told before, there are many significant tests are available in statistics to check the model is good or not, like z-test, t-test. So these are some technical statistical tests that we use in our models. So coming to TensorFlow. So TensorFlow is a framework developed by Google for building a machine learning models. It's particularly useful for deep learning applications. For example, if you're developing a neural network to recognize images, then TensorFlow is must to incorporate in your machine learning model. So this is also a package. It is available in Python. Why I have separated this package is because this is very important when you are building a image processing models like tumor prediction or cancer diagnosis. In that kind of model, this TensorFlow plays a very crucial role. So coming to Jupyter Notebook is nothing. It's a platform where you will build a model. And SQL database, in the sense SQL, structured query language, is essential for managing and querying the database. So whenever you need to retrieve specific data from a large database, SQL is the tool you use. For example, if you're working with a database of customer information, you might use SQL to find all the customers who made a purchase in the last month, right? So can you give any other example for database?
SQL, MySQL, MongoDB.
Okay. So let me go to the next slide. So AI integration with the data science. Let's talk about how artificial intelligence integrates with data science. An easy way to think about this is AI is like a brain, while data science is like the eyes and ears, providing information that to to be blind. So these are the 5 steps that every data scientist will do. First, data collection and preparation is the first step. This is the, like, for example, if you're building an AI to predict house prices, you need data about house features, locations, and prices, etc. So this data must be accurate and clean to use this in our model. So first we have to do is cleaning the data. For that, we will do exploratory data analysis. This is a technical term, but I'm not getting deeper into this. Let's see the second step, that is feature engineering. So in this step, the data scientist will pick out important parts of data to help AI understands better. So continuing with the house price prediction example, the important feature might include the number of bedrooms, the size of the houses, and the neighborhoods. So these features are extracted and prepared for an AI model. So these features are important to predict the amount, estimated amount for the house. So next is model training and optimization. Here the data scientists train the AI to do its job well using a special techniques, like they'll feed the data into AI model and adjust it to improve the quality of the model. And next is evaluation and validation. So once the AI model is trained, it needs to be tested to ensure it works correctly or not. And coming to the deployment and monitoring part, finally the data scientists set up this AI in real life and make sure it keeps working smoothly or not. So this is the final step after building the model. So introduction to machine learning. So machine learning is a subset of artificial intelligence that particularly focuses on developing algorithms and models that allow computers to learn and make predictions or decisions based on data. Like we can say sport prediction in IPL. Nowadays we are predicting the score based on the previous scores that they have worked as a team to get high scores. We can predict the scores for the next IPL seasons also. So this comes under time series. And now let's see some of the examples. The tumor detection. This machine learning is used to detect tumor in medical images by training algorithms on thousands of images of tumors. So the computer can learn to identify patterns that indicates the presence of tumor. So this actually helps the doctor to diagnose whether there is a tumor or not. So coming to image recognition, think about how Facebook or Instagram suggest tags for your friends and when you upload a photo. So this is machine learning. This work is done by machine learning actually. And signature forgery detection. So detecting forged signature, like in banks and finance institution, use machine learning models to compare a signature against a known genuine one. The model learns to spot discrepancies that might indicate forgery, like we use in our phones to unlock our mobile using our face. And that is the great example for image processing and computer vision also. We'll see what is computer vision in the upcoming slide. And the signature forgery detection. So machine learning helps in detecting forged signature. Like in banks and finance institution, we use machine learning models to compare a signature against a known genuine one. The model learns to spot discrepancies that might indicate forgery. Like imagine in banking system there may be fraud happening due to this forgery signature. So this image processing is used in banks and some finance industries to recognize whether the signature is original or fake. So these are the types of machine learning: supervised machine learning, unsupervised machine learning, and reinforcement learning. I'm not going in deeper into the technical terms, but let me explain you with a real-time example. So coming to supervised machine learning, let me take an example of predicting house price. So imagine you have a dataset containing information about various attributes of houses like bedrooms, size, location, and let me take number of bedrooms and the actual sale of these houses. So each house in dataset have these features like location, size, bedrooms along with its corresponding actual sales price. So now we are essentially teaching the model to understand how different factors like location, size, bedrooms influence the price of a house. This is the estimated price. based on these attributes. By showing its examples from historical data, where we know both features and the actual price, the model learns to make predictions. So it's like teaching a student to solve a math problem by giving them examples with answers. So what this machine learning will do is it will learn from data and answers, and it will predict the price, estimated price for the house for the unseen data. And this is unsupervised machine learning. So let me take an example of social media content discovery. So imagine you're on a social media site where people share all kinds of things like stories, pictures, and videos. There's so much of content being posted all the time. So now imagine the site wants to help you to discover new stuff you might like. So nowadays we see some recommendation system. When we go into Instagram, we'll see some reels that we have seen in our friend's phone, which is like she have liked that reel, so that in that clustering, so this comes under clustering part actually. So what this will do is, the site uses a smart system called clustering. It will like putting similar things together in groups. So if you like one cute cat video, like a reel, the site might suggest more cute cat videos because you're in the same group. It's like saying, hey, if you liked it, then you might also like all these things. So this is like unsupervised machine learning. And this is reinforcement learning. Let me take an example of teaching a robot to navigate. So that let me take a scenario. Like imagine a little robot in a room filled with obstacles like chairs and tables, and its goal is to reach at other end of the room. Like now the robot needs to learn how to move around the room without colliding things. When it successfully reaches the goal, that's like a part of good thing. When it collides with something, it's not so good, right? So that's the robot job, is to figure out how to move around smoothly to reach the goal without any collision. So in simple, imagine like you're playing a game with a robot. So every time it reaches the goal, you give it a high five, and every time if it hits something, you will say oops. So the robot learns from these experience. It tries to different parts and remember which one lead to success and which one leads to failure. So eventually from this, it learns to navigate the room smoothly. So this is how reinforcement learning works. Like it learns from failures and success. So these are the types of regressions: linear regression, logistic regression, and decision trees and random forest. These regressions will be changed based on the context of the model. So I'm not getting deeper into this because these involve some of the technical terminologies. Coming to time series. So time series analysis is like looking at timeline for events to understand how things change over time. So imagine you're tracking ice cream sales at a beachside shop throughout the year. So in January, when it's cold, fewer people buy ice cream. But as the weather warms up in June and July, sales peak up. So then again, gradually decrease when the weather cools down in September and October. So understanding these patterns helps the ice cream shop plan better. Like they know to stock up on the flavors in summer months, and maybe they have to give offers and discounts in the colder months to boost their sales. So coming to the next part, so the time series have these 4 components associated with it: trend component, seasonality component, irregularity, and cycle. So let me explain what is trend component with the same ice cream example. So despite the fluctuations due to weather or other factors, there's a general upward trend in the sales from January to July. And again, it will follow a downward trend from July to December. So there will be either an upward trend or downward trend despite the fluctuations. So coming to seasonality, in our ice cream sales example, the seasonal component would account for like increase in sales during summer months and decrease during the colder months. So this pattern will repeat every year, right? So this is called seasonality. And irregularity is something like, there may be an individual days or weeks where the sales will be deviate from this pattern due to factors like sudden weather changes, or special events or other unpredictable factors. So this leads to irregularity. There is a change, there is a deviation in the seasonal patterns is called irregularity. And in our ice cream sales example, a cycle component might capture a long-term trend influenced by other factors. So this is how cycle, trend and seasonality irregularities differ from each other. Using these patterns, we will forecast the future sales. So this is the forecasting methods. There are 4 methods totally: moving average, exponential smoothing, ARIMA model, and seasonal decomposition. So this is also a technical term, but I'll explain you in a simple way. Like moving average, moving average smooth out the fluctuations in the data by calculating the average of specified number of neighbors. And exponential moving average, it will give the least weight to the, more weight to the previous observation and least weight to the day before observations. And it will forecast based on the future previous sales. So that is, exponential smoothing assigns more weight to the recent data points while gradually decreasing the weights for the older data points. And it helps to capture the short-term changes in the trends. So ARIMA model, this is very technical. So this actually helps to forecast by including all the components like trends, seasonality, and stationary. And seasonal decomposition also includes the residual, which means error. So error in the sense there is a change between the actual price and the estimated price. So this component will be also included in the future prediction. So these are the techniques for forecasting the future sales or future predictions. Introduction to big data. So big data simply refers to large and complicated set of information that are hard to handle and analyze using regular methods. So we cannot use any regular methods to analyze because, as the name suggests, this is a big data. So big data is known for its 3 V's, that is volume, velocity, and variety. Volume in the sense there is a lot of data, like having a huge stack of papers to go through. And velocity comes to you at a very fast time, like a stream of water rushing by. So this is very fast, that's its velocity. And variety in the sense it's made up of all the kinds of different things, like having a mix of photos, text, and numbers. It will have all the kind heterogeneous data types. So that is variety. So in simple terms, big data is like trying to organize a gigantic pile of stuffs that constantly growing and coming to you a very quick time. So this is about big data. Now let's see the types of big data. So structured data, unstructured data, semi-structured data, and streaming data. So structured data in the sense like it's like information neatly organized in a box. Like think of it as a customer information neatly arranged in a table in the database, where each row represents a customer and each column represents a specific piece of information like name, age, and email. This is a neatly organized data. When it comes to unstructured data, like it's a messy pile of papers with no clear order. It lacks a specific structure, making it challenges to organize and analyze using any traditional methods. Example, in social media, posts, emails, videos, they are all examples of unstructured data because they don't fit neatly into a rows and columns like structured data. So coming to semi-structured data, actually semi-structured data is a blend of both unstructured and structured data. So it also goes into a technical way. So example is XML. Next, coming to streaming data. Streaming data is like continuous flow of information that keeps coming in real time. It's like constantly generated from various sources like sensors, social media, or we can even say satellites. Pictures, data from sensors in smart city monitoring, traffic in real time, and social media feeds. So these are the examples of streaming data. So I think you can understand what I told you. So this is the example that I told you previously. So now introduction to computer vision. So this is similar to image processing, and here computer vision is like giving eyes to machines, allowing them to see and understand the world around them. So imagine teaching a computer to interpret and understand what it sees, just like we do with our eyes and brain. That's what computer vision is all about. It's the branch of artificial intelligence that helps computer make sense of visual information like pictures and videos. So Some of the practical applications of computer visions are facial recognition, autonomous vehicle, and medical imaging analysis, augmented reality. So in, like, we can see in autonomous vehicle, we can take the example of Tesla. So think about Tesla car driving. Instead of relying on solely on human driver, it uses sensors and computers to detect other vehicles, pedestrians, and road signs. It's like having a digital assistant with us. So next image, medical image analysis, like it's like assistant doctor to diagnose the disease, as I told you, tumor prediction. And augmented reality adds digital information or virtual objects to the real world, enhancing our perception of reality and creativity. So let me give an introduction of deep learning. Deep learning is a branch of artificial intelligence again. So that trains the neural network. So here, neural network comes into the concept. A neural network with lots of data to make accurate predictions. It differs from traditional machine learning by using more complex neural network architecture with many layers, allowing it to learn and interact with some data, and it will predict the patterns out of it. Now, both machine learning and deep learning make predictions from the data, but deep learning is better suited for handling large and messy data sets. So this had, you can think about examples of phone camera. The traditional method might rely on predefined features like nose, eyes, but deep learning algorithms can learn to recognize faces by analyzing thousands of examples, leading to more accurate results. That means it will predict your face more accurately by assuming some patterns in your faces. It will recognize more accurately than other traditional systems. So these are the key concepts in deep learning. As I said, neural network layers. So there will be many layers which is getting output from the previous layers. So with this, it will provide a most accurate information. So training in the sense, it's like you provide them with examples, correct their mistakes, and gradually refine their problem solving skills until they solve similar problems on their own. It's like just giving a training to a machine. And the activation function is more technical, so I'm just skipping that term. So these are the applications of deep learning, as I said, in computer vision. Same image recognition, natural language processing, healthcare, and autonomous vehicles. So natural language processing focuses on understanding and generating human language. It powers chatbot and translation services, voice assistants like you can say Siri and Alexa, allowing computers to understand and respond to human speech. So this is how natural language processing is defined. So coming to career paths in data science, so there are data scientists, data analysts, machine learning engineering. So the role of data scientist is like they are like detectives. They're digging through the data to find answers and make predictions out of it. The skills required is statistical analysis, machine learning, and programming. And coming to data analysts, they are like translators. They are tuning the data into stories the business can understand and use to make decisions like translating the language. And skills required for this is data visualization. Coming to machine learning engineering, they are like builders. So making tools that can learn from data and making decisions, same as data analysts, but here we will develop some machine learning tools or models. So the skill required here is machine learning algorithms and some packages. Like I said before, TensorFlow is very important packages when it comes to machine learning. Data engineer. So they are like architect and they are like design. They are used to design and building the structure that holds data, making sure everything runs smoothly. So they have those responsibilities. When it comes to skill, database management, and there are some technical terms associated with the data engineer. So some basic foundations are SQL, Python, and the same Python libraries that is used for machine learning engineers or required for this data engineering also. And business intelligence, so they'll create pictures with the data, helps to understand what's happening and what to do next. So they work under like what to do if something happened in the sales. So they are responsible for this, and the skills are similar for all the domain. The same data visualization tools, Tableau and Power BI are used to see the graph, and we can analyze some patterns with that. And SQL same as before, and some of the technical terms again associated with that. And statisticians, so they are like math experts using members to solve problems and make predictions. So data architect, they are like city planners designing and managing the layout of data system, ensuring everything is organized and efficient. And the skills associated with this is similar to all the domain that we have seen before. And AI research scientists, they are like explorers discovering new ways to make computers smarter and more useful. And data consultant, they are like advisors helping business make sense of data and guiding them on how to use it in a best way. So why there is a high demand for data scientists? Because there is a rapid growth in data, and nowadays there is increase in decision making systems. So there are many adoption for AI and machine learning technologies, and there is a shortage of professionals to do this job. That's why data scientist job is in peak. So data scientist salary in India we can expect the entry level salary typically ranges from 5 lakh to 8 lakh annually, and mid level salary usually falls between 10 lakh to 15 lakh annually, and senior level salary can exceed 20 lakh to 30 lakh or more than that. So yeah, lots of industries are on the lookout for data scientists these days, like software companies, banks, hospitals, online shopping sites, factories, and even government offices. They all are hiring data scientists. Why? Because they all have tons of data that they want to make sense of it. Whether it's like improving software predictions or in government sectors, they need data scientists to make sense of the data that they are having with them. Factors influencing with salaries. So as you know, locations, experience, education, and the industry where you're working, all this depends depends how much salary you are getting. Like location salary tend to be higher in tech hubs like Bangalore, Mumbai, and Hyderabad, where the demand for data scientists is also high. So experience, as with many professionals, the salary increase significantly with years of experience. So in education, advanced degrees such as master's or PhD can lead to higher salaries. So in conclusion, data science is like a treasure map in digital age. Like it helps us to dig deep into piles of data around us, finding gems of information that guide and make predictions out of it. With the roles like data scientist and analyst in high demand, there's a lot of excitement and there's a lot of opportunity in this field. But more than just data science is about turning raw data into insights and making a real difference in the world. It's about using information to make things better, whether it's improving either business, healthcare, or our daily lives. So as we move forward, let's keep exploring and analyzing and discovering about some new insights, and we can, in this world, data science, there are too much things to uncover and learn. So that's it. Thank you for joining me. Any questions or suggestions?
Thank you for the presentation. Since I have been understanding the spots, I have a doubt. You have been telling that R, Python, and so many additional things we need for the analysis part. So, if you want to start with a particular thing, means will you recommending both Python and R at the same time, or any one of thing is better for the starting the DA?
Yeah, at the initial stage of your career, I recommend Python is best suited because Python have many ready-made packages. As I told you, to build a machine learning model like TensorFlow, NumPy, and there are many packages to test and train. So these are readily available in Python. So this will be better than R programming. But when you're a domain expert in software industry, then at that time you'll use R programming. But initial stage Python is more than enough.
Okay, thank you.
Any other question?